What's up, everyone? Hope you're doing well today. Today, we're talking omega-3 and omega-6 fatty acids because the last video discussed of how the omega-6 ratio to omega-3 ratio can cause a cascade of inflammation and other things like autoimmune disease, eczema, allergies, more severe cases of asthma attacks, colitis, a lot of things that are linked to the excess of arachidonic acid in the cell, although it is needed, but the proper ratio is important. So I did a blood panel and got the ratios and the amounts of omega-3s and omega-6s that are in my blood, and it was pretty interesting. But first, I want to talk about what each one is and how it kind of plays a role in the body. So, the first one that is probably more known as EPA, which is eicosapentaenoic acid. And eicosapentaenoic acid plays a role, the primary role in, or at least in research shows its benefits against inflammation, cardiovascular disease, arthrosclerosis, and inflammation in the endothelium of the vessels. But essentially, how it works is it competes on the same COX enzymes as arachidonic acid. So it creates a lesser prostaglandin, PGE3, versus PGE2, and it's a more resolution approach to inflammation. And the cleanup crew, when macrophages come in, instead of them attacking everything and making it more like a war zone, this shifts the mood to a repair, rebuild, and move out method. Uh, and much like autoimmune disease, like rheumatoid arthritis, like your body is not attacking itself. So EPA is well known for its anti-inflammatory effects and roles in the body and plays a big role in clotting factors. So, EPA is a producer of thromboxane A3, which is comparative to thromboxane A2, TXA2. Thromboxane is a platelet aggregator, so it helps with clotting so that you don't bleed out. But a thromboxane A2 is more aggressive and could lead to clotting inside the vessels itself, especially if you have damaged endothelium due to plaque buildup and excess cytokines that damage the endothelial walls. So the production of thromboxane A3 is more advantageous because it is a more homeostatic approach where if a clotting factor is needed, it is there, but it isn't a self-eating snake where the clotting factors are over excessive. So, on the note of the endothelium and arthrosclerosis, it's more of a compounding effect of cytokine damage in the cell walls rather than just pinning it on LDL because you get damage to the endothelium, then you get the immune response, and where macrophages come in, LDL that is oxidized gets trapped in that damaged area. Then macrophages come in and engulf that LDL, creating a foam cell. That foam cell creates like fatty streaks on the lining, leading to plaque buildup. And then that plaque could potentially break off, leading to heart attack or stroke. So, the benefit of having less inflammation in the endothelium is absolutely a good thing. And again, omega 3s compete for the production of a lesser hammer down approach on the inflammation cascade. The next one we'll talk about is docosahexaenoic acid, DHA. So, interestingly enough, this one is more known for brain health and eye health and even semen health, but it makes up 60% of the cell membranes in the brain uh, and shows a direct correlation to inhibiting amyloid plaque buildup, which is a direct link to Alzheimer's, clearing out neuroinflammation and helping with neuroplasticity, so better learning. It also helps upregulate BDNF, which is brain derived neurotropic factor, one of the strongest producers of this is exercise, and brain derived neurotrophic factor is essentially fertilizer for your brain, allowing for neuroplasticity, less neuroinflammation, and greater synapses between neurons. So, better learning, better memory, better focus, better feeling. And then over 50% of the cell membranes in the retina are also made up of DHEA, and specifically in the photoreceptors in the back of the retina, you have rods and cones. Rods are more for the night vision and motion, and then cones are more for color and detail, so kind of the HD. So it specifically works on a protein called rhodopsin, which is the protein that allows light to come in, it flips and then has to recycle continuously. So the DHA specifically helps the rhodopsin recycle quicker, allowing for clearer vision, better visual acuity, better vision at night, and less halo on lights at night if you're used to seeing that. And also, it shows a benefit to help with macular degeneration and myopia in children, which is like elongation of the eye, leading to nearsightedness. But a very common anecdotal remark of taking omega 3s is people see a huge reduction in dry eyes and clearer vision, sharper vision. So, these doses that typically have the greatest effects are 2 to 4 grams per day. It can be challenging to get those levels from just food because you find it mostly in fatty fish like salmon and mackerel. Sardines have it, but it is challenging to eat that much seafood for a lot of people. And also, you have to consider like mercury content drastically increases due to eating fish, but it's because the fish eat algae and the algae then produces and metabolizes into the omega 3s inside the fat of the fish. Whereas in humans, it's not nearly as bioavailable and metabolized. The algae isn't. So that's why you get it directly from fish oil. So get it from a good source, though, if you are supplementing, because there are some wonky ones out there, which I'll dive into a little bit at the end, what to look out for in getting a supplement of omega 3s. And then DPA, which is docosahexaenoic acid. This one is interesting because it's more emerging in research and seeing that it's a link between EPA and DHA and how they can work in the body and also be stored. So it's potentially a storage of these omega 3s and releases as needed. And DPA helps regulate that and then convert them. The reason they believe, or this research is emerging like this, is because they found in cattle specifically that were primarily fed grass fed diets from Australia were much higher in all omega 3s, and the concentration of DPA was very high in their muscle tissue. So the Australian grass-fed pasture-raised cows have higher levels of omega-3 versus omega-6 versus their American counterparts that are primarily grain-fed that have very high levels of omega-6 concentrations. So of note, grass-fed beef is not a comparable level of omega-3 versus like a salmon. That is kind of the common argument of like, oh, it doesn't have that much, but it's still important to know that if you get a grass-fed animal, it's going to be much higher ratio-wise of omega-3 to omega-6 benefiting you in the end, because then that's going to increase your ratio. Just goes to show it's not what you eat, it's what your food eats. It's an important thing to understand. DPA also is prominent in mother's milk. So it'd be very important for mothers and nursing mothers to either get a adequate amount of omega 3s through food or supplementation. And the research has shown that there's been over the past 50 years, there's been a lack of omega 3s in baby formula, and then has led to higher instances of ADHD, hyperaggression, cognitive learning. So IQ scores were lower in the individuals that were tested and had a lower level of omega 3s in them, and can become easily depleted if the mother is not eating enough sources of omega 3s or supplementing, because we in the bodies we cannot produce fatty acids like omega 3s or omega 6. So we have to get them through nutrition or food. Of note, the testing or trials they did on Inuit people that consume primarily massive amounts of fats from seafood had great levels of cognition, had minimal instances of cardiovascular disease, and they eat almost all fat from fish. So pretty interesting to talk about how heart health is directly correlated with fat intake, because they also did research, and the meta-analyses show that it's actually beneficial for heart health, and improve omega-3s improve cardiovascular disease prevention, reducing triglycerides, which are fatty acids that you find in the blood, and atherosclerosis, and the connotation of high cholesterol is bad isn't necessarily true if you are not having oxidized cholesterol. So specifically to that, you see an increase of triglycerides not just from fat intake. You see it because the liver goes through this process called de novo lipogenesis. And de novo lipogenesis is just new fat creation. When you intake carbohydrates and sugar, the liver stores excess glucose. And when you have excess glucose in the liver, it doesn't have anywhere to put this energy. So it goes through de novo lipogenesis, then creating more fats, triglycerides. Then it packages them in VLDL, very low density lipoproteins, and then pushes them out to be utilized as energy or stored if there's an excess of energy. So when people come off a high carbohydrate diet or an excess of sugars or fructose and things of that nature, they see a sometimes up to 90% decrease in triglycerides and cholesterol markers. A big piece of that is whether your cholesterol is oxidized or not, because again, endothelium health matters. And when you have damage to the endothelium, then you combine that with oxidized LDL, the LDL gets stuck in the endothelium. Then the macrophages come in to do their job to engulf the damaged substrate. That creates a foam cell. Then that foam cell gets stuck as plaque and then can break off again. So it's more nuanced than just saying high LDL, and that goes into a whole nother discussion. But the omega-3 has been a powerful mechanism in reducing cardiovascular events, and specifically EPA and DPA are fairly effective against inflammation because they are precursors to that prostaglandin E3 and then help create resolvins. And resolvins are essentially a resolution to inflammation at a lesser compounding effect to make it bad for the body. So the resolvins make it more of a build, like a remove and build the problem rather than attack the problem. So the resolvins are super beneficial, and they've seen it in reduction of certain cancers and reducing of TNF, which is tumor necrosis factor, and then the proliferation of cells, which is just excess growth leading to different cancers. So it's very interesting to say the least. And then looking at the results, go over some of the ratios. So, looking at my blood panel here for the omega-6 to omega-3 ratios, not too shabby. So, EPA, DPA, DHA, that's the total result, 9.1% by weight. So, getting a total measurement of omega-3s in the fat in my circulating blood. Higher percentage suggests the optimal levels that are seen with reduced risk of chronic diseases, while lower percentages mean there is a need for increased dietary intake or supplementation. So then you look at arachidonic acid and EPA ratio. So the arachidonic acid to total eicosapentaenoic acid ratio, and we'll scroll down and show the arachidonic acid levels, but it essentially divided the two to give a 3.6. And that's good because you want low levels, you want a better ratio, and the ratio valuable predictor of cardiovascular risk. A higher ratio is associated with a higher risk of major cardiac related events. So I like the red on here. I think anybody would agree that that red is good because you want the low levels. And then this is the total omega-6 to omega-3 ratio. So it's just taking the linoleic acid and the arachidonic acid omega-6s, dividing it by the EPA, DHA, and DPA, and giving you a ratio. And if you remember, we talked about having a ratio of 4 to 1 or 2 to 1. So I'm right underneath that at 3.8 to 1 ratio. So I'll make some tweaks in the nutrition and see if I can't get it even lower. But EPA total 3.1, which is high on their scale according to them. But uh yeah, you want all the benefits of anti-inflammatory coming from the EPA, then the docosahexaenoic acid ratio. So this is one that I would attribute to because majority of my diet is primarily grass-fed beef, and DPA is harder to find. You can get it in supplementation, but some supplements are lacking it. But because it was present so high in the Australian grass-fed beef, I would attribute that a higher level is probably because I only primarily eat grass-fed beef as my calorie intake 90% of the time. So, and then the docosahexaenoic acid. I also take a supplement too that is one that I researched pretty in depthly because we'll go into why it's important to have a good omega-3 supplement as well. But here's the number: they took the 33.3% and divided it by the total omega-3 number 9.1, and that's what gave the 3.8. 4 to 1 ratio is good. I'm at 3.8 to 1. So total arachidonic acid, lower ish. And then, arachidonic acid is that metabolite of excess omega-6 linoleic acid. So reducing omega-6, then you can get less arachidonic acid, therefore less inflammation. Although you do need a small amount of arachidonic acid, less than the 21 to 20 to 1 ratio that we see in the Western diet. A couple things to note when you're picking out a supplement, if you decide to supplement with omega-3s, there's a lot of supplements out there that aren't the most advantageous form. And if you're wanting to reduce the amount of inflammation and oxidative stress that you have in your cells and in your body, to get a supplement that is not a high quality that could introduce more oxidation would be a bad thing. So, things to consider when you're getting an omega-3 supplement: if the capsule and the bottle itself aren't light proof, UV will oxidize that omega-3s, which is a pretty fragile fatty acid. So if it's a clear bottle, no bueno. If it's a clear capsule, probably not. They're probably not like looking out for the best interest of the oxidation of that product. A big thing you'll see is tocopherols, which is a component of vitamin E, and vitamin E is a powerful antioxidant and helps reduce the oxidation of the omega-3s in the supplement themselves. You should see is mixed tocopherols, because if you only there's alpha, beta, gamma, and delta. A lot of times the cheaper supplement brands will only use alpha because it's easily synthesized and mass produced, so they'll put tocopherol alpha in there. But you should see beta, gamma, and delta. They all bring their own attributes as to why they're powerful antioxidants, and then combining them all, they each give a different feature of bioavailability. Speaking of which, the transport carrier is typically on cheaper supplement is going to be an ethyl ester versus a triglyceride. So you want an omega-3 that's carried in a triglyceride because it's up to 90% more bioavailable and absorb better, and also leads to less like fishy burps. If you get the right one, you won't have any weird burps or fishy taste, or you shouldn't at least. And then another powerful thing about the oil itself is like you'll see with krill oil is like a ruby red color. That's astaxanthin, which is a carotenoid that essentially makes the salmon a red color. So if you have a ruby red fish oil that has a protective coating that isn't just clear, and you don't have just one alpha tocopherol, then you're probably getting a good supplement. So those are all things to consider, because if you aren't getting a quality product, you're introducing more inflammation because you're intaking an oxidized oil already, which essentially wouldn't be any better than intaking excess omega 3s. So all this stuff plays a role. And if you want to get your blood panel done, specifically for the omega-6 to omega-3 ratio, that would be a pretty proactive thing to do to reduce things like inflammation, potentially autoimmune diseases, rheumatoid arthritis, cardiovascular risk, amyloid plaque buildup. There's a litany of things of how it could be beneficial, especially if you're looking at lowering triglycerides. Also, should consider removing refined carbs. That would decrease it significantly. But uh, yeah, something great to ask if your provider will do for you. If they don't, then you can do what I did and just go pay out of pocket and order online, and then go get it blood drawn with other panels that you want to do. There is an option to order it on like Amazon. You do like a finger prick and then send it back in. Could be potentially less accurate because it's not taking a serum sample right then and there, but also an option. So not a bad idea to get them checked. Not a bad idea to try and consume and offset that ratio to your advantage of omega 3s better by eating a quality source with low mercury content from fatty fish, through grass fed beef. And if needed, and if you decide that's correct for you, then to do supplementation. Thanks for tuning in. And if you want to read some more on the website, check out solutions2wellness.org blog for all the things I discussed on the channel. Like, subscribe, and share.